Hey guys, and welcome to Notes 3-2. We're talking about the remainder and factor theorems. In a summarization, really what we're doing in this lesson is talking about the different ways to divide polynomials. This is going to be a skill that we are going to need in the next few lessons within the chapter and several other times within the year. So it's handy, and it's just a skill that's required. All right, let's go ahead and begin. The first type of division we're going to do is long division. So we're going to set up the long division just like we would any long division of numbers. The part that we're dividing by goes on the outside. The polynomial that we are dividing into goes on the inside. So we're going to go ahead and do this division. Now the first question that we are going to ask ourselves is this. What multiplied by x will give me this 3x cubed? And if you think about that, that would have to be a 3x squared. And notice that I lined it up with the column of the x squareds here. Now I'm going to multiply the 3x squared by both the x and the negative 1. So we do 3x squared times x and 3x squared times negative 1, and we get a negative 3x squared. Notice when I write these, I do have to line them up under their appropriate column. All right, very important. Now, with long division, at this point, we subtract. So I'm going to draw that line, and I'm going to change both signs. Since I'm subtracting a binomial, I have to subtract both of these terms, and subtracting the negative 3x squared is really positive. So now we do the subtraction, and we get a 0, which tells us we're on the right track, and I get a 10x squared. Just like long division of numbers, I drop the next term. Then we do the same division. What times x would give me 10x, or 10x squared rather? Well, that would be a 10x. 10x times x is 10x squared. 10x times negative 1 is negative 10x. And what do? We draw the line and we change both signs. Do the subtraction. Once again, 0 says you're on the right track, and we get an 8x. Drop the negative 8. And then we do what times x gives me 8x? That would be an 8. 8 times x is 8x. 8 times negative 1 is negative 8. If we draw the line and change the signs, notice that I get a remainder of 0. All right? Now that remainder of 0 is going to become important. What that tells me is that what I just divided by was indeed a factor. So really, I know that this polynomial has an x-intercept at positive 1. And that's what we're going to ultimately use this for within chapter 3. Let's go ahead and move over and do the next problem. And in fact, I would suggest if you're watching this video for the first time, why don't you pause it after I set this up and give it a try on your own. And then you can click play and we can work it out together. All right? That way you can see if you're on the right track, because this is a review topic. All right, to go ahead and get started though, we have x times what to give me the 2x here in the first term, and that would be a 2x squared. 2x squared times x would give me a 2x cubed. 2x squared times 3 is a 6x squared. Draw the line and do what? Well, change both signs. Remember that step, please. When you subtract, you do get a 0. That means we're doing good. And then we get a 3x squared. Drop the 13x. What times x gives me 3x squared? Well, that's a 3x. 3x times x is 3x squared. 3x times 3 is a 9x. Draw the line and change both sides. We're going to go through, do the subtraction now. Once again, we're on the right track. And we get a 4x. Drop the 6. What times x gives me 4x? Well, 4. 4 times x is 4x. 4 times 3 is a 12. Draw the line, change those signs. We get minus 4 and minus 12. This leaves me with a remainder of negative 6. Now, when we bring this remainder up, we're going to do minus 6 divided by x plus 3. We're always going to put it over what we divided by. All right? And that's long division. Now, we've got a second type of division that we're going to work with, and that is called synthetic division down here. Now, whenever you are dividing by a linear term, synthetic division is really what we would like to go to. All right, I don't do long division unless the polynomial is a quadratic or something of that nature. And you're going to have some in your homework, some linear, some quadratic. When it's a linear polynomial and if we're being divided by a linear term rather, please use synthetic division, much nicer. With the synthetic division, this is how we're going to set this up. Put a little box, skip a line, and draw the line. Now, the numbers here, we are first going to take the opposite. What would make the x minus 1 0? And that'd be a positive 1. You change that sign and put it in the little box. The coefficients of my polynomial are going to go across here. So I have a 3, 7, -2, and -8. The first number is going to drop straight down, 3. And now it's going to be multiply, add, multiply, add. So I'm going to do positive 1 times 3, and that's a 3. I add this to the 7, and I get a 10. Then I do positive 1 times the 10, and I get 10. 10 plus a -2, that's an 8. And then 1 times 8 is 8, and 8 plus -8 is 0. You've probably already noticed that this is the first example that we had done, and yet you notice that the solution doesn't look exactly the same. What's missing, you may say? Well, the x's are missing, the variables. So this is where we're going to put the variables back in, and it's important to keep it in mind. We started with a third-degree polynomial. We divided by a first degree, so what's going to happen with the powers is that we drop by 1. So we've got 3x squared plus 10x plus 8. The last one is always our remainder, and we had a remainder of 0 here. Okay, awesome. Let's move on. And this is really what we're getting ready for. Now, this is the factor theorem. The factor theorem says that if you divide a polynomial and you get a remainder of 0, then that factor was a factor of the polynomial. If what we are dividing by gives 0, we have a factor, and that's really going to be the key for the rest of the chapter. So let's look at the next example over here. Example, it says find the remaining zeros of the polynomial given that 7 is one of them. So what we have here, we know that 7 is an x-intercept. That x minus 7 is a factor. We want to find the rest. Now, the first thing that we're going to do with that 7 is we are going to divide the polynomial. Because it was just a single term here, we can use synthetic division, and that's really going to be our go-to method most of the time. Remember that 2 drops straight down. 7 times 2 is 14. 14 minus 9 is a 5. 7 times 5 is a 35. 35 minus a 32 is a 3. And 7 times 3 is a 21. We get a 0. Now, once again, why is that 0 important? 0 tells me that it tells me this. It tells me that when I plugged in 7, I get 0, which means that x equals 7 is an x-intercept. All right? That's where we check this. Now, what is left over? Well, the part that's left over down here, if we put the variables back in, we have a 2x squared, we have a 5x, and we have a 3. That, my friends, is a quadratic. We can solve a quadratic by many different methods. You could factor it if it's factorable. You could use the quadratic formula. If you're kind of weird, you could complete the square, I suppose, if you wanted to. Most people don't choose that. But we've got a bunch of different methods to solve these quadratics. That's the key. This quadratic happens to be factorable. So notice if I set it equal to 0, I'm going to factor using the mistake method. 2x plus 2x plus 2 times 3 is a 6, and I'm looking for factors of 6 that add to give 5. Well, that'd be a 3 and a 2. We always put the biggest number first. And now, do you see where my extra 2 is? It's not in the first parenthesis because I can't divide both of those by 2. It's in the second parenthesis. So when I remove the extra 2's, I'm left with x plus 1. So the full factored version of this is 2x plus 3 and x plus 1. What does that mean? What are my x-intercepts? Well, that means that my 2 remaining x-intercepts are -1 and -3. 3 over 2. That's in essence a preview of what we're going to be doing for the rest of the chapter. The only difference is, starting next time, I won't give you the first number. That's going to be up to you, but I'll help you with some techniques on finding it. All right, that's lesson 3-2. Thanks for watching, and hopefully the computer will save this, or else I'll be sad. Have a good night.